What up, what up? I'm the math teacher Goat, and today we are doing a full lesson on no way. Sine, cosine, and tangent. Trigonometry begins in AP Precalculus. As usual, go to the description and download the notes. Follow along. Also, like and subscribe. All that good stuff. Let's jump right into it. All right. We got a 6-pager, a rare 6-pager. The graph of the function f is given in the xy plane. Which of the following functions has the same period as f? So let's find the period of f. You pick any two spots that it definitely repeats. So I'm going to pick the very tippy top, and I'm going to pick the very tippy top, and it's at the x distance that it takes for it to repeat. So last time I checked, 5 minus 1 is 4. So one of these has to have a period of 4. So do you have a period of 4? Tippy top, 8 minus 0 is not 4, so not you. Tippy top, 4 minus 0 is 4, so you. Let's just double check the others because, you know, why not? Let's make this video a little bit longer. Always gets me more YouTube money. Tippy top, 4.5 minus 2.5 is not 4, so not you. Tippy top to tippy top. So if you're 4, 6, 8, you'd be 10, you'd be 12. So 12 minus 4, last time I checked, 8, 4, baby. Not D. So it looks like we did everything just fine. All right. Now, in geometry, you were introduced to a little acronym. I guess it's called an acronym. I'm not really good at this stuff. Called SOH CAH TOA. And SOH CAH TOA gives you all the trigonometric relationships for sine, cosine, and tangent as it relates to an angle of your choice. So we're going to take a look at each of these three angles, theta, theta, and more theta, and you have yourselves a right triangle. Now, with a right triangle, according to theta, you're always going to have the longest side, which is always going to be your hypotenuse. Then you'll have an adjacent side and an opposite side, depending on what your theta is. Okay, so I didn't mean to do that, but it just so happened. It just so happened. So stands for sine of theta equals the opposite side over the hypotenuse. So you choose your theta and you go the opposite side over the hypotenuse. Cosine theta means you're going to choose your theta and you do the adjacent side over the hypotenuse. And tangent means you're going to choose your theta, and it's going to be the opposite side over the adjacent side. SOH CAH TOA. Now, how does that apply to these three problems on the bottom? Well, it gives you the angle that we need to focus on. So tan z means we're going to choose z, and tangent is going to be TOA, the opposite side over the adjacent side. So, according to z, the opposite side is 21, and the adjacent side is 28. I don't care about your hypotenuse. So, tan z is the opposite side, 21, over the adjacent side, 28, which those are divisible by 7, so 3/4. So, tan z is 3/4. Okay? Sine A. There's my angle in question. Sine is SOH. SOH stands for opposite side over the hypotenuse. According to this right triangle, the opposite side of A is going to be 32, and the hypotenuse, doesn't matter what A is going to be 40. So sine of A is going to be the opposite, which is 32, over the hypotenuse, which is 40. Both divisible by 8, so you got 4 over 5. Now we have cosine. We have cosine of A, so there's A. Cosine is CAH, which is, I believe, what Paul Walker called Tyrese in Too Fast, Too Furious. Look it up. It's a great line. He's like, leave me alone, CAH, or something like that. Of course, rest in peace, Paul Walker. Cosine stands for adjacent over hypotenuse, CAH. So adjacent over hypotenuse. So the adjacent side, and let me be clear, The adjacent side of A that is not the hypotenuse is 30. The hypotenuse, no matter what, is 34. So according to A, the adjacent side is 30. The hypotenuse is 34. Both divisible by 2, so that gives you 15 over 17. All right, so if you remember from geometry, you should have learned that towards the end of the year. But yeah, that's basic SOH CAH TOA. Basic SOH CAH TOA. Some more definitions, may be brand new, may not be brand new, is we have angles in what's called standard positions. Now, what we're going to look at 90% of the time is we are going to look at an angle where you begin on the positive x-axis and you rotate it counterclockwise to create an angle that we'll call theta more often than not, and then you end on what's called this terminal side. So an angle is in standard position when the vertex, right here on the origin, coincides with the origin, and one ray coincides with the positive x-axis, which is this guy. Okay, we call that first ray the initial ray, always on the positive x-axis. The other ray is called the terminal ray. We always measure the ray starting at the positive x-axis, and we always go counterclockwise. Always, 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 always. So we're going to go in that direction. Okay? So just to get some vocabulary and just to get some understanding in, name all of the angles that are in standard position. Give the initial ray and the terminal ray of each angle. So angle number 1 is going to be U and U. So I can call this angle CDB, so angle CDB. My initial ray is ray DC, which is a mess, political stuff. And terminal ray is ray DB. Of course, when we name a ray, we start out with the endpoint first, and then the ray is the last part. Now, that is one of our standard angles, or angles in standard position. I guess I should word that better. The other one is going to be U, U. So I will call that angle CDA, angle CDA. I could also call it angle ADC. My initial ray, just like last time, is DC. And my terminal ray is what my kids call me. Most people view angles in degrees. So you might remember that. So for example, 90-degree angle right there. So, 45-ish degree angle right there. We don't do that anymore. The idea of using degrees in AP Precalculus is dead. Okay? Most people view angles in degrees. In AP Precalculus, we use radians, where pi is 180 degrees. So instead of saying 90, we would say pi is 180, so half of 180 is 90, so half of pi. You would be a quarter of pi because you're a quarter of 180. So on and so forth. Okay? So a general look as stolen from the internet is if we were to talk about angles in standard position, right, using degrees, we would usually go in this direction. Every time you rotate, you hit 360. Well, now we're going to be looking at it as radians. Okay, so we start at 0, and an angle that normally looks like it's 30 degrees is going to be pi over 6. An angle that looks like 120 is going to be 2 pi over 3. An angle that looks to be 21, 0, is going to be 7 pi over 6. The idea is exactly the same, but we are not going to be using degrees at all in this class. Not once. I don't think it's going to pop up for any reason whatsoever. Okay, so it's very important that if you don't know how to read radians, you do that right now. And understand that if you want to calculate what radians is versus degrees, you're basically comparing everything to 180. Okay, so if I were to visualize what 150 is in radians, you're going to do 150 over 180, attach a pi. Knowing that both of these are divisible by 30, so divide u by 30, divide u by 30, and so 150 is the same as 5 pi over 6. Okay? So know that, love that, pause it, memorize it, you're going to need it. Now, what we're going to deal with a lot in AP Precalculus is me not drawing straight lines when I'm trying to, maximize here. Is the idea of the unit circle. So not only are you spinning things around, you are connecting it to a circle. Now, the unit circle is a circle with a radius of 1. Okay, so the radius is 1. You are always r and you are always 1, and so we're spinning you around. Give an estimate of how many radians the angle here represents. All right, so look, I know that half of u is 180 and 180 is pi, which means you're pi over 2. So halfway in between pi over 2 and pi is going to be 3/4 of a pi. So that's what I would estimate you to be. You're pi over 2, you're nothing. So halfway in between 0 and pi over 2 is 1/4 of a pi. That's what I'll write you out to be. You're in quadrant 3, so you're pi, so you're 1.5 pi, so 3 pi over 2. And you know what? I don't need to use fractions. You can't make me. I'll say 1.4 pi, leave me alone. And if you wanted to turn that into a fraction, that's 14 over 10, which is 7 over 5, so 7 pi over 5. Whatever you want to do, leave me alone. Now, if you have negative angles, that means you went clockwise. And what you may need to do to fix that is add 2 pi, so you can see as to where it should be. So for any reason, if I were to give you, and I don't want to erase it, but I'm just going to add like a little addendum here. This right here is negative pi over 4. That would make sense. If going pi over 4 ends up here, then going negative pi over 4 ends up here. Well, we went the wrong way. So how can I make that positive? Just add 2 pi. And that would get you, let me see, 7 pi, not 7 pi. That would get me, 7 pi over 4. 7 pi over 4, because it would be 8 pi over 4 added to that. Angles greater than 2 pi, look, that just means you spun around. So if I spin around to 3 pi over 4, cool. If I go another 2 pi, I land in the same exact spot. So 3 pi over 4 and 11 pi over 4 are the same thing. So if that happens, you just need to subtract 2 pi to get what you want. When angles are in between 0 and 2 pi, they are called coterminal angles and sometimes referred to as reference angles. We want our angles to always be in between 0 and 2 pi. So when that doesn't happen, we need to make it happen. And so what we do is if it's negative, you add 2 pi until you get in between 0 and 2 pi. So if you add it 2 or 3 times, then you add it 2 or 3 times. If it's above 2 pi, then you subtract 2 pi until it's in between 0 and 2 pi. So this is gross 43 pi over 18. So what I need to do is understand that, all right, well, 2 pi turned into something pi over 18 means I'm going to multiply the top and the bottom by 18. So that gets me 36 pi over 18. So I'm going to add 36 pi over 18 and see if I land in between 0 and 36 pi over 18. So negative 43 plus 36 pi is going to be negative 7 pi over 18. Not what I want. So I need to add another 36 pi over 18. 36 pi plus negative 7 pi is going to be 29 pi over 18. That is smaller than 36 pi over 18, so I'm gold. Okay, So 29 pi over 18, I guess you could use a calculator to really find out what it is. But chances are that's going to be, let me see, it's bigger than, let me see, 29 pi over 18. I'm just going to estimate that it's going to be around here somewhere. I mean, negative 7 pi over 18 is, yeah, maybe a little bit lower, 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 maybe somewhere around here. Like that. Now you're in the same exact boat, but the numbers are a little bit nicer, right? You're way much bigger than 2 pi. So I'm going to say, let's subtract 2 pi, but I need to make it over 4. So multiply the top and the bottom by 4. So that gets to be 8 pi over 4. So I'm going to keep subtracting 8 until I get what I want. Minus 8 pi over 4 is going to get me 11 pi over 4. Not what I want. Minus 8 pi over 4 is going to get me 3 pi over 4. That is in between 0 and 2 pi, which is 8 pi over 4. And we already know that 3/4 of a pi is that perfect diagonal right there. Okay? All right, that's that for that page. All right. An angle with a measure of 5.7 pi would be equivalent to which of the following angle measures? Well, you're way too big. So it's not like we're trying to get one that's coterminal or reference. We're just trying to get one that matches up. So let's keep subtracting 2 pi until we hit all of these possible options. Minus 2 pi is going to be 3.7 pi. I don't see it. Minus 2 pi is going to be 1.7 pi. I went beyond 2.7, so that's not going to work. Minus 2 pi is going to be, we'll be careful, negative 0.3 pi. So let's keep going, negative 0.3 pi minus 2 pi is going to be negative 2.3 pi. So I went beyond u. Minus 2 is, I'm not going to hit anything 0.7, that's negative, so it's not going to be u. So it's going to be d and d only. All right. Now things get to be super important. Super, super, super important. You saw way back when that sine, cosine, and tangent follow the SOH CAH TOA rules. Okay, so sine of an angle is going to equal SOH, which is opposite over hypotenuse. Cosine of an angle is CAH, which is adjacent over the hypotenuse. And tangent of an angle is TOA, so opposite over the adjacent. Okay? Now, theta is always going to live right there. If I'm looking at a circle, okay, I can create this triangle where the radius is always going to be my hypotenuse. Always. Where my x then is going to be adjacent and y is going to be my opposite. So if I were to view this as a point, x, y, on a coordinate plane, right, xy on a coordinate plane, then sine theta is going to be the opposite side over the hypotenuse, which is going to be y over r. Cosine theta is going to be the adjacent over the hypotenuse, which is x over r. And tangent is going to be the opposite over adjacent, which is y over x. Memorize this, memorize this, memorize this, memorize this, memorize this. And what's really, really, really important is if tan theta is y over x, that means I go up and over. That's my slope. Tangent's the same thing as slope. Tangent means slope. Memorize these three guys. You're going to use them all the time, starting now. So I give you a circle with a radius that appears to go from here at the origin all the way to 6. So my radius is r. Okay. It intersects a point, 2.6, negative 5.4. And my job is to find sine alpha, cosine alpha, and tan alpha. So what I just wrote up there is sine is y over r. So according to this, sine alpha is going to be negative 5.4 over 6. Now, I guess we can simplify that, but I'm not going to really worry about simplifying it. I'm going to leave it like that for now. Cosine is x over r. I just wrote it up there. X is 2.6, r is 6, so we'll leave it like that. 1.3 over 3 if you want to do it. Tan alpha is our slope, y over x. Look, we're going down and to the right, so we're going to have a negative slope. Y over x is going to be negative 5.4 over 2.6. So I'll rip out that negative and write it out as negative 5.4 over 2.6. Okay? Very important stuff. Now, that was when we have any radius. What if I give you a unit circle when r is 1? Well, that would mean that sine theta, which used to be y over r, is now just y. And cosine theta, which used to be x over r, is now just x. Tangent theta doesn't change. So basically, whatever that point is, if r is 1, I could say that x is just cosine theta and y is just sine theta. And the tangent is just the slope. So when I see this problem right here, it gives me a radius of 1. So you are cos theta and you are sine theta. That point right there. So what's sine theta? Well, we're using alpha. So what's sine alpha? Well, just negative 0.76. What's cos alpha? Well, just negative 0.65. And tangent alpha is just going to be my y value over my x value, so negative 0.76 over negative 0.65, and we're not going to lose any sleep trying to simplify anything. So 0.76 over 0.65. Okay? Easy peasy lemon squeezy. So radius of 2, so you would be my x, you would be my y. Sine is going to be y over r. So sine is going to be negative 0.5 over 2, which actually simplifies nicely to a quarter, right? But we're not going to worry about that. Negative 0.5 over 2. Cosine theta is going to be x over r, and x is 1.937 over 2, so we can leave it at that. And tangent theta is y over x, so negative slope for sure. So negative 0.5 over 1.937, so let's just rip the negative out front and leave it like that. Radius is 1, so the rules change a little bit. So you're automatically cos theta, and you're automatically sine theta, although they're using alpha, right? You're my x, you're my y. So if r is 1, then sine alpha is just going to be 0.9798. Cosine is going to be negative 0.2. And tangent is going to be my y, which is 0.9798 over negative 0.2, so let's rip that negative out and make it 0.9798 over 0.2. Notice that radius has nothing to do with tangent because tangent just means slope, so I don't care how long that line is, it's going to be the same slope anyway. So that the end of that page? We're just flying through this thing. And of course, ugly problems at the end. Ugly problems at the end. In the xy plane, angle ABC is an angle in standard position with terminal ray BC, which intersects the unit circle at the point with coordinates 0.6, negative 0.8. Which of the following descriptions is correct? So let's make ourselves a unit circle. It says unit circle, so we're assuming the radius is 1. I'm always so awful at drawing unit circles. There we are. Thank you, Internet. So what's my point? Positive, negative, so positive 6, negative 8, so we'll put something over there, right? So we have an angle, goes over here, ends up over there, spins around that way, and we're calling it nothing. We don't even have an angle measure. But we know that that point is 0.6, negative 0.8. So they want information about the signs and the signs only. Sine is going to be y over r, or in this case, just y, because r is 1. So it's just u. So the sine of angle ABC is negative 0.8. An angle theta is in standard position in the xy plane. Which of the following is true about theta on the interval between 0 and 2 pi if cosine is less than 0? All right, so we're talking about an angle or a unit circle. Cosine is my x value. So cosine less than 0 means we need a negative x, which lives in quadrant 2 and lives in quadrant 3 because negative x's have me go to the left. So whatever this is going to live in either quadrant 2 or quadrant 3. So there is no value of theta on this interval for which cosine is negative. No, that's definitely not true. There are values of theta for which cosine in all 4 quadrants. Nope, only 2 and 3. There's a value for which cosine is in quadrant 2 only. Nope, it's 2 and 3. And there are values for which it's in quadrants 2 and 3. Kind of a bizarre problem. Very bizarre problem, but I don't know. I guess the point is to make you realize that cosine is x and x is negative on the left side of the y-axis. Now, this is where it's just a really ugly, gross-looking problem. I really hate this problem. The figure shows a circle centered at the origin with an angle of measure, theta radians in standard position. Okay, there you have it. So there's my angle. Bang, goes to P. The terminal ray of the angle intersects P, and point Q also lies on the circle. The coordinates of P are xy, and the coordinates of Q are x negative y. So what that tells us right there, so far what I know, is the angle that I care about goes to P. P is xy. Q is the same exact x value and the same exact y value, just negative. So if you're something like 2, 4, right, you're 2, negative 4. I'm just making up points, and it can't even be 2. Because that 2, the radius is 2, we'll see if that has anything to do with anything. I don't know. Which of the following is true about the cosine of theta? So what we know about cosine theta at this very moment is cosine theta is going to be x over r. I know that x is x, right? And r is 2. So theta associates with P has nothing to do with Q. Okay. Cosine theta is x over 2, which is correct because it is the ratio of the horizontal displacement of P from the y-axis to the distance between the origin and P, which is correct because you're moving left or you're moving right, then you're moving up. So it's the ratio, okay. Cosine is not that, so you're not correct. Cosine theta is y over 2? No. And cosine theta is y over 2. yeah, I don't know, man. Sometimes these AP problems just don't make any sense. But, basically, we found out what cosine theta was based off of this information. Q had nothing to do with nothing because Q didn't have anything to do with theta. So basically, horizontal displacement means your left to right movement. That's what X is. And your distance between the origin and P is your radius. Boy, did I hate that one. But I didn't hate that lesson because I do enjoy sine, cosine, and tangent. So we're now getting into the thick of trigonometry. That's just the beginning. Like and subscribe. Make sure you go to my YouTube and type out AP Precalculus 3.2 so you can watch my random AP Precalculus examples. Each of these have like 7, 8, 9 problems that you can watch just to help further your knowledge, just in case my notes don't seem to do the trick. But that's that. Thank you for watching as always, and I'll see you in the next lesson. Bye.